Okay, in this lesson, we're going to look at solving compound inequalities. And basically, a compound inequality, one version looks like this. Now, you could also see uh, compound inequalities having the word or having the word and. Now, this right here, you're going to see later on that that would be an and inequality, an and compound inequality, AND. But for right now, we're just going to look at it in terms of what we see. So one of the things I want you to notice is that if I covered this part up, then this would be a simple linear inequality that you solved before. And so notice it's just one inequality symbol. If I were to cover this part of the problem, then you have that same situation. So you have a simple linear inequality that you solved previous lessons ago. What makes it a compound inequality is the fact that this expression right here, that 3x minus 2, is less than or equal to 8, and at the same time, it is greater than a negative 1. And so one thing that helps students to recognize that this is a compound inequality is that you have a variable expression in the middle, and then you have two inequality symbols. Okay, so this is a compound inequality. Now, to solve a compound inequality, you want to find out what values of x will make this expression less than or equal to 8 and at the same time greater than a negative 1. That's what you're trying to find. And to solve this, you're going to isolate the variable x in the middle. Now, the process of solving a compound inequality is the same as you would do if this was a simple inequality. So if you look at this, and from previous lessons, how would you get x by itself? Well, this is a simple linear inequality, and so one of the things I can do is I can add 2 to both sides. That would be the first step. But remember, this is a compound inequality, so there are basically 3 parts. 1, 2, 3. The left, the middle, and the right. And so there are 3 parts. So if I add 2 to the middle, then I have to add 2 to the outsides as well, to the other parts. So you have to do this. So notice add 2, add 2, add 2. Now we're going to combine like terms. So when I combine like terms, I get negative 1 plus 2 is a positive 1, is less than, just bring it down just like we're doing, combine like terms, that's 0, so I'm left with 3x in the middle, and that's less than or equal to 8 plus 2 is 10. Okay? And then if I cover this part up again and you're solving this linear inequality right here, how would you get x by itself? Well, right now I'm multiplying by 3. The opposite is to divide by 3. So we divide this part by 3, this part by 3, but remember we are dealing with a compound inequality, so I've got to divide this part by 3. And now I've found my solutions. So 3 divided by 3 is 1. So all of my solutions, the variable x, all of my solutions are between the numbers 10/3 and 1/3. So that's all your solutions. So every real number between 10/3, including 10/3, instead of the equal sign, and then greater than 1/3 as well. Now notice there's no equal sign here. All right, so that's your solution in terms of an inequality. Okay, now you need to also state the solution as an interval notation. So interval notation, so let's talk about that. So you've already talked about the idea of interval notations when you first talked about solving linear inequalities. But notice that the values of x here, my solutions, are between 2 numbers. They're between 2 numbers. So the largest solution is 10/3 and the smallest solution is greater than 1/3. Okay? And so how you're going to do this is this. So remember, if there's no equal sign, you use parentheses. If there's an equal sign, you use brackets. So you're going to say parentheses, no equal sign, parentheses, 1/3, comma, and then 10/3 with a bracket. All right, so remember, there's no equal sign here, so parentheses. There's an equal sign here, bracket, and so your solutions are between 1/3 and 10/3. So that's the interval notation. There's also another way that you may see your solution written, and that's called set builder notation. Set builder notation. So let's talk about set builder notation. So set builder notation is going to look like this. It's going to say, so you're going to have a set, braces like this. It's going to look like that. And it's going to say the set of, and your variable is x, so it will be the set of x's such that, so this means right here, the set of x's such that. So this vertical symbol right here means such that. Such that, this right here means such that. And then all you do is rewrite this inequality right here in here. So you're going to say such that x is less than 1/3, I'm sorry, is greater than 1/3, and at the same time, it's less than or equal to 10/3. And that's it. So there are a couple of problems on MyMathLab where you have to state and set builder notation. So all you do for this part here, you just rewrite what you have here. That's all it is. And then finally, you have to graph. And so since you're doing this by hand, then all you do is this. So just put 1/3 here, just like this. Put 10/3 here, just like this. And then you put, now you need to use parentheses or brackets in MyMathLab and on the worksheet. So you're going to say parentheses like this, bracket like this, okay? And then you're going to shade in everything between them. Everything between them, okay? So parentheses, see how they all build upon each other? Parentheses, parentheses, bracket, bracket, and then you shade it in. Now let me say this. There are some textbooks that will do this as well, and that's fine. So they'll put 1/3, 10/3, and then since there's no, since this is a parentheses, since there's no equal sign, parentheses, you're going to put an open circle, just like that. Okay, now bracket, equal sign, bracket, bracket, you're going to put a closed circle. So parentheses corresponds to open circle, bracket corresponds to closed circle, and then you shade in everything between them. Okay? But this is the one that you're going to see on MyMathLab. You're going to see parentheses and brackets. Now you could see, depending on the textbook, you could see open circle and closed circle. All right. Now that idea is going to be important when we talk about functions later on as well. All right, so that was number one, and so it's basically the same idea you've been doing. All the process is the same as you did with just solving linear inequalities, except this time it's a compound inequality. Okay, let's look at number two. Now, number two, we have this in number two. So we have, let's say we had -2 is less than 4 minus 5x is less than 7. So -2 is less than 4 minus 5x is less than 7. Again, notice this is a compound inequality. You have your variable expression here. You have two inequality symbols. And always notice those inequality symbols are pointing in the same direction. Less than, less than. If I go back to the previous one, they're pointing in the same direction. Less than, equal to. Okay? So they're not going to be in opposite directions. You will never see, because it doesn't make sense, you will never see less than and then greater than. It will always be pointing in the same direction. Okay, so if we look at number two, we have this. All right, so remember the idea is to get the variable x in the middle. And so just like you've been doing before, if you need to, cover this part up and ask yourself, well, how can I get -5x by itself for right now? Well, I can subtract 4 from both sides. So I subtract 4 from both sides. But remember, you have a compound, so you got to do it here as well. So there are three parts you have to subtract 4 from. Now let's combine like terms. A -2 and a -4 is a -6 is less than, remember this is 0, so you get -5x. And then less than, and then 7 subtract 4 is 3. Okay? All right, now if I cover this up and you ask yourself, well, how can I get the variable x by itself? Well, right now I'm multiplying by -5, and the opposite is to divide by -5. So I'm going to divide both sides by -5, both parts. But remember, this is a compound inequality, so you have to do this as well. Okay? Now, here's the thing you got to remember. So you have to remember that you are dividing you are dividing or multiplying, in this case I'm dividing, or multiplying an inequality by a negative number. So you learned it previously that whenever you divide an inequality by a negative number, you must change these inequality symbols. So you must reverse them. So now what I have is this. First of all, notice that a negative divided by negative is a positive, so this is 6/5. Since I divided by a negative number, this less than becomes greater than. Okay? And then negative 5 divided by negative 5 is 1. 1 times x is x. This less than becomes greater than. And then this is negative 3/5. Okay? Now, here's how you want to rewrite this. So you see how when we write our interval notation, we always go from smallest to largest. 1/3 is less than 10/3. Okay? We always do that. Always go from smallest to largest. Well, what you notice here, oh, and by the way, when you look at this part as well, this is the smallest, this is the largest, okay? But when I look at this right here, notice that 6/5 is not the smallest. Negative 3/5 is smaller, because remember, negative number is always smaller than a positive number. So what you want to do is rewrite it in a different way. So you're going to say negative 3/5 is less than x is less than 6/5. All right, so you're going backwards. So you're just going backwards. So negative 3/5 is going to be this. So negative 3/5 is the smallest, right? So negative 3/5, and this right here indicates that all the x's are greater than negative 3/5, and at the same time they have to be less than 6/5, and that's what you see there. And now once you write it like this, then you can tell me the interval notation. So interval notation must always be from smallest to largest. So that's why it's important you do this. Notice that there are no equal signs on either one, so you can use parentheses in both cases. So negative 3/5, comma, 6/5. Okay? And then, so what you found is that every real number between negative 3/5 and 6/5 will make this compound statement a true statement. All right, so for example, y'all agree that 1's in here? So 1's in here, right? So first of all, notice there's an infinite number of solutions. So when we went here and we graphed the solution set, notice that there are an infinite number of solutions. That's why we graph it. We shade it in like this. We can't list them. There's an infinite number of real numbers in here, so you got to graph it by using shading. And so the same thing here. So I have an infinite number of solutions, but I do know that the number 1 is one of them, because 1 is between these two numbers. Okay? Because 6/5, remember, is 1 and 1/5. So 1's in here. So let's see why it's true. Okay, so I'm going to just do it by pointing at it. Well, let's go ahead and let's just check x equal 1. So x equal 1 is a solution, right? Okay, so if I go back to the original problem, negative 2 is less than 4 minus 5x is less than 7, and I substitute 1. Watch what happens. Negative 2 is less than 4 minus 5 times 1, x is 1, is less than 7. 4 minus 5, well, 5 times 1 is 5, right? So this becomes negative 2 is less than 4 minus 5 is less than 7. And so 4 minus 5 is a negative 1. And so the question is that a true statement? Is negative 1 less than 7? So is negative 1 less than 7? Yes. If I cover this part up, is negative 2 less than negative 1? Yes. So that's why 1's is a solution. But again, how many solutions are in here? There are an infinite number of solutions. I just went ahead and checked 1. Okay? Now, let's do this for a moment. Let's see why y'all agree that 2 is outside of here, right? So let's see why 2 is not a solution. So why is 2 not a solution? All right, so let's see. So we're going back and plug in just to show you. All right, and so 5 times 2 is 10, so I get negative 2 is less than 4 minus 10 is less than 7, and then 4 minus 10 is a negative 6, right? Okay, all right, now watch. So let's see why 2 is not a solution. So is negative 6 less than 7? Yes, so that part's true, but here's the problem. is negative 2 less than negative 6? No, negative 2 is greater than negative 6. So that part is not true. Okay, so that's why 2 is not a solution. So basically what you found here is that the solutions to this original, to my compound statement would be any real number between negative 3/5 and 6/5. Now I chose integers, but remember real numbers could be fractions, could be decimals that are anywhere in here. Okay? All right, so there's your interval notation. Then let's talk about set builder notation. So set builder notation. So when I do the set builder notation, you're going to say this. You're going to say the set of x's such that, and then all you do is rewrite this part in here. So such that negative 3/5 is less than x is less than 6/5. And that's set builder notation. And then you're going to graph it. And so since you're doing this by hand, all you do is this. You just draw a number line like this. And then you put negative 3/5 first because that's the smallest. Negative 3/5 is less than 6/5. Put 6/5 next. And then let's use parentheses and brackets. Notice there's no equal sign, so they're both going to be parentheses like this. And then you shade in. Don't forget to shade in because remember you are graphing the solutions. So there are an infinite number of solutions between these two numbers that will make this compound statement a true statement. And then if you use open circles and closed circles, which some textbooks do and some parts of my math lab will, then again you do the same thing. Negative 3/5, 6/5, open, open, and then you shade in. Now let me say something. When you do this by hand, you got to make sure that what you are showing is a parentheses. If it looks like it's a bracket, you're not going to get full credit for this. You got to make sure you make it look like a parentheses, and you have to make sure that you make it look like a bracket. Okay, same thing here. Make it look like an open circle, make it look like a closed circle. Because if there's any part of this that kind of doesn't look like what it's supposed to be, then you're not going to get full credit. Okay, so that was number 2. So it's not that bad. Okay, let's look at number 3. So number three, we have this problem. All right, so number 3. Okay, we have negative 4 is less than or equal to 2/3 x minus 1 is less than 6. All right, so we do have a fraction this time, but we know how to deal with fractions. You've dealt with it in previous situations. So again, if I cover this part up to get the variable x by itself, you would add 1 to both sides here. So same thing, except this time you're going to do all parts. And so negative 4 plus 1 is a negative 3 is less than or equal to, and then this is 0, so you're left with 2/3 x is less than, and 6 plus 1 is 7. All right. Now, if I cover this part up again, notice how I have a fraction here, so you can multiply both sides by the LCD, which is 3. And so let me go ahead and leave some room. So you're going to do this. Leave some room here. That's less than 7. So you're going to say times 3, times 3, times 3. Okay? So you're multiplying every part by 3 to get this right here to clear the fraction. So negative 3 times 3 is a negative 9 is less than or equal to these 3's divide out, and you're left with 2x is less than, and then 3 times 7 is 21. And then all you do now, just like you did before, to get x by itself, you can divide all parts by 2, and so you get negative 9 halves is less than or equal to x is less than 21 halves. Okay? All right. Now, so let's talk about, so there's your solution set in terms of an inequality. So all my solutions are between these two numbers, negative 9 halves and 21 halves. Okay, now, if you want to, and that's okay, but on my math lab, they're going to ask you to leave them as fractions probably. But if you want to, you can change these to improper fraction, to mixed numbers. So negative 9 halves is negative 4 1/2. And then 21 halves is, what's that? Let's see, 2 into 21 will be 10 and 1/2. So that's 10 and 1/2, right? Okay. So your solution, so you can write either one of those, it does not matter. Okay. Now let's talk about interval notation. So your interval notation, okay, so remember that's where you're gonna go from, remember, interval notation, you go from smallest to largest. Okay, so notice there are equal sign here, and I forgot the less than here, and there's no equal sign here. So with equal sign, you use brackets, and you're going to say bracket -9/2 or -4 1/2, does not matter, comma, all the way to 10 1/2. But remember, that is no equal sign, so 10 1/2 is not a solution. So we're going to use parentheses. Okay? And then set builder notation. So for set builder notation, you're going to say the set of x's such that, and then all you do is rewrite either one of those. It does not matter. So rewrite that over. So -9/2 is less than equal to x is less than 21/2. And then the graph, for the graph, all you do is just list these numbers. It doesn't matter which one of these you use. The improper fractions or the mixed numbers, does not matter. So you just rewrite those. Make sure you put the smallest on the left and the largest on the right. And then you use parentheses or brackets. So since there's an equal sign here, notice it corresponds to this. So bracket on -4 1/2. And again, make sure the bracket is on that little tick mark. See, I drew those little tick marks. Make sure it's on that, and then parentheses here. Okay, and so you shade in. Make sure you shade in, and so there's the graph. So that was number 3. Let's look at number 4. Number 4, we have this. Okay, so we have -3 is less than 2x plus 3 divided by 2 is less than equal to 8. So -3 is less than 2x plus 3 divided by 2 is less than equal to 8. So again, sometimes it helps if you cover part of the problem. So we have this compound inequality. And so if I had this situation, remember we could clear the fractions. So we're going to multiply both sides by 2. But in this case, I would have to do all 3 parts by 2. So we're going to rewrite this over. So 2x plus 3 divided by 2 is less than equal to 8. So you're going to say times 2 times 2 times 2. So I get -3 times 2 is a -6 is less than these 2's divide out. You're left with 2x plus 3 is less than equal to 16. Okay? And then next thing I'm going to do, if you cover this part up to get x by itself, you have this linear inequality right here. So you're going to subtract 3 from all parts. And so I get -6 and -3 is a -9 is less than 2x is less than equal to 13. And then finally, all you do is divide by 2 and you found your solutions. So when I divide by 2, my solutions are between -9/2 and 13/2. All right, so those are your solutions. So your solutions to this compound statement will be any real number that's between 13/2 and -9/2. So that's what you found. So there's an infinite number of solutions, infinite number of real numbers. So then when you do the interval notation, when you do that, you're going to get, remember, since there's no equal sign, that's going to be parentheses. Since there's an equal sign, you use brackets. You can say parentheses -9/2, comma, and then 13/2 with a bracket. Set builder notation. So if you look at set builder notation, we have the set of x's such that, and then you're going to say you just rewrite this over right here. And then you're done with that, with set builder notation. Now the graph, so remember the graph, you always go from smallest to largest. So the smallest is -9/2. And again, you can use mixed numbers if you want to. And then 13/2. So we can do parentheses here. Remember these correspond, -9/2 parentheses. And you see that little tick mark, make sure that you draw the bracket over that tick mark like this. Okay? And then you shade in. So those are your solutions. And again, if you want to use parentheses and And I'm sorry, if you want to use open circles and closed circles, you can. If the direction says if the direction says you must use parentheses and brackets, then it must look like this. Okay, so now what I want to do is let's look at number 5. Let's look at the next one. So number 5 we have. Okay, so number 5 we have this. We have this compound inequality. And this is not a difficult one. Those are no fractions, but I want to at some point say something about this. So again, the first thing you're going to do is add 1 to both sides, or actually all 3 parts. So I get 3 is less than equal to 3x minus, is less than equal to 3x is less than 6. 5 plus 1 is 6. So let me go ahead and rewrite this over. So 3 is less than equal to 3x is less than 6. All right, so again, the next step, remember, is going to divide to divide by 3. We're going to divide all parts by 3. So I get 3 divided by 3 is 1. It's less than equal to, this is just x, is less than 2. So I found my solutions. Again, there's an infinite number of solutions here, infinite number of real numbers. And so all of my solutions to the original compound inequality will be every real number that's between 1 and 2, including 1, not including 2, because there's no equal sign. And remember, there are an infinite number of real numbers here. You have 1.5, you have 1 2/3, and so on. So there's an infinite number of solutions in here. So the interval notation, will be from bracket 1 all the way to 2 with parentheses. So the bracket corresponds to the equal sign. So 1's a solution, so you need a bracket. 2 is not a solution, so you need parentheses. Okay, and then the set builder notation will look like this. The set of x's such that, and you just rewrite this over, such that 1 is less than equal to x is less than 2. And then the graph, your graph will look like this. You have 1, you have 2. There's a bracket over 1, so wherever you say the 1 is, you got to put a bracket right over that tick mark. And then parentheses over 2, and then you shade in. So notice all these numbers in here, all these real numbers, 1.2765, 1.89432, and so on. So all these real numbers, there's an infinite number of real numbers in here. Okay? Now, when students think of real numbers, they think of just whole numbers. You got to be careful. Integers or whole numbers are not the only real numbers. You have all kinds of decimals in here. All right, so the infinite number of those. Okay, what I want to indicate though is this. So you see where we said a while ago when I talked about this, I said 1's a solution, so we use a bracket. 2 is not a solution, so we use parentheses. Okay, so you learned about that in a previous lesson. So for this one, let's go ahead and see why 2 is not a solution. So we know that 2 is not a solution, right? So let's see, why is x equal 2 not a solution? Not a solution. Now y'all know it's not a solution because of the parentheses, but let's see when we substitute why it doesn't work. So go back to the original. We're going to write the original problem over. 2 is less than or equal to 3x minus 1 is less than 5. So wherever I see the variable x, I'm going to substitute 2. So I get 2 is less than 3 times 2 minus 1 is less than 5. So let's simplify the middle part. 3 times 2 is 6. 6 minus 1 is 5. Okay? All right, now here's the situation. So do y'all agree, first of all, that 2 is less than or equal to 5? That's your true statement. Okay? But what makes 2 not a solution is this. Is 5 less than 5? No, 5 is not less than 5. 5 equals 5. So that's why 2 is not a solution. So then let's look at 1. Why is 1 a solution? So why is 1, x equal 1, a solution? So again, same thing. If I rewrite the original problem, the original compound statement, if I rewrite it over, I get, and I substitute 1, I get 2 is less than or equal to 3 times 1 minus 1 is less than 5. 3 times 1 is 3. 3 minus 1 is 2. So I get this. Okay? Now let's see why it's true. Let's see why 1 is a solution. Do y'all agree that when I substitute 1, I get this statement? Is this true or false? Well, that's a true statement. 2 is less than 5. All right, now let's get the other one. If I cover this part up, is that a true statement? Is 2 less than or equal to 2? Yes, it's equal to. You see, that equal sign makes it a true statement. Here, there was no equal sign. It strictly said that 5 is less than 5. Well, that's not a true statement. 5 is not less than 5. 5 equals 5. So that's why. 1 is a solution and 2 is not a solution. So that's why you see a bracket over 1, parentheses over 2. Okay? Okay, now, one more, and let's look at this one. So in this one we have, this will be number 6, we have 0 is less than or equal to 2 times x minus 3 plus 3 is less than or equal to 5. Oops, let's do the variable n. I want to do n just to show you something. So I'm going to use n here. In all the other problems I used x, but there could be problems in my math lab where the variables are not just x. So let's do this one where the variable's not x. So if you cover this part up and you look at this in a previous lesson, you know how to deal with this linear inequality. You're going to use the distributive property first. So if I do the distributive property first, I'm going to get 0 is less than or equal to 2n minus, and then 2 times negative 3 is a negative 6, and then plus 3 is less than or equal to 5. So again, cover this up, combine like terms, this a negative 6 and a positive 3 is a negative 3, so this becomes 0 is less than or equal to 2n minus 3 is less than or equal to 5. And then the next thing you're going to do to get the variable n by itself, you got to first of all now add 3 to both sides, or in this case all 3 parts. And so I get 0 plus 3 is 3 is less than or equal to, this is 0, so you're left with 2n is less than or equal to 8. And then finally you can divide all parts by 2. And so I get 3 halves is less than or equal to n is less than or equal to, in this case, 4. Okay? And so your interval notation, you're going to say bracket 3 halves, comma, 4 with a bracket. Your set builder notation, now listen carefully to this part, your set builder notation, you remember when we did the set builder notation in previous problems, we said the set of x's? We used x because that was our variable. So now we're going to say this. We're going to say the set of n's. You got to use the variable that's in your problem. The set of n's such that, and then you just rewrite this over. So 3 halves is less than or equal to n is less than or equal to 4. And then your graph, you're just going to say, you put the smallest first, the largest on the right. And so both of those are going to be brackets because they both have equal signs. See the brackets? So you can say bracket, make sure it looks like a bracket. So at first I kind of mess this up. So I'm using a pen, but if you're using a pencil, you may need to erase it. And then bracket, and you shade in. Don't forget to shade in. Some students forget to shade in. So if you don't shade in, you're only indicating that there are only 2 solutions, the ones and the ends. But you have an infinite number of solutions in here as well. Okay, so that is the lesson on solving compound inequalities.